Okay, so for this problem, it's worth noticing that the first 3 digits add up to 6. So they must occupy the red positions that you're seeing on the screen. We don't know what order they go in, but we know that 1, 2, and 3 go there, and they can't go anywhere else. So the next smallest numbers, 4 and 5, or to make 10, we have to add 1 to them. So 1 has to go in the middle row, and 4 and 5 are going to go on the middle row too, in the green dotted cells that you see. We don't know which order they go in yet, but we know that they occupy those two. So if we look at the next smallest number around the edge, we look at 15. We've used 4 and 5 up, so the next smallest numbers are 6 and 7. And to get to 15, we must use 2. So 2 has to go on the top row in that red column. And 6 and 7 are going to occupy the last 2 positions. Now it stands to reason that 3 must occupy the third empty square in the first column. Also, quite quickly we deduce that 8 and 9 must go in the bottom row. Now if we look at the smallest column remaining, 18, and we take the 3 smallest numbers that could go in the blue, green and black positions, 4, 6 and 8 add up to 18, so they go downwards through the columns in the correct rows. And we're near enough done now. We now can, because we knew we had a choice of 2 in each of the rows in those positions, it's just the other 2 numbers that go into that middle column. And we check that they add up to make 21, and they do, and we're done.